So continuing on the Heron code overview. So we have now delving into more of the Heron core directory itself, which is at the top level directory, and we are drilling down one more level. And the root of this review is going to be the Heron directory itself. So these the multiple subdirectories are organized into three top tier components. One is called API, another logical organization called tools, and finally the core, which is essentially the function of the core functionality of the Heron itself. So on the API itself, like there are two directories that belong to this API component, and that is the directory API itself, and there is a directory called SPI. So API essentially exposes a Heron level API that allows you to say how the topology should look like, and what are its methods, and what are spouts, bowls, and all the various other things. On the other hand, the SPI essentially like allows you to add its core functionality to Heron itself. For example, in the case of uploader, how you can add your own uploader. Similarly, in the case of a state manager, how can you add yet another state manager. So those kind of things are in the SPI, and the expansion for SPI is called the service provider interface. So the next logical component is called the tools, Heron tools, and the tools consist of multiple parts. And the first one is the CLI, which is the Heron CLI that you use to submit jobs and kill the jobs or kill topologies, those kind of things. And that's all part of the Heron CLI. And the Explorer is yet another component that we did, like to kind of have an operational overview of what are the topologies that are currently running, and what are its corresponding metrics that we want to do, what are the total number of clusters that we are operating on, and how to get the list of topologies running on each cluster, and what are its configuration, and all those various other elements. So the third one is actually called tracker, and the tracker allows you to tap into the various state managers of Heron when it is running, and get corresponding the list of topologies and the state of those topologies and everything. And tracker you can think about as a gateway for both Explorer and the CLI to query information about the topologies. So the last one is the UI, where you, once the UI is installed, allow you to explore your topologies, how it's running and where it is running, where its containers are scheduled, and what are the metrics that are being collected for each one of those containers, and what are the instances that are running on those containers and the corresponding metrics. And similarly, you can have access to all the Heron instance logs and all the various other aspects you can do via the UI. So now the last one is the core itself. The core consists of a lot of directories, but don't get intimidated. It's pretty simple. The first one is a common directory. So within the common directory, if the code is being used by several other directories, the common directory is the one where you kind of add the code to. So that, and within each directory, it's organized by the languages. For example, if common source CPP means it's a C++ file, if it's common source Java means it's a Java file, and common source Python means it's more of a Python files. So that's how the common and other directories are organized. The second one is the config. The config provides a lot of several sample configs for each of the scheduler that Heron can run on. I mean, today Heron has a lot of code that runs on Aurora, as well as Yarn, as well as Mesos, as well as Slurm. So all the example configs are available in this config directory. So the examples directly gives you a head start about some topologies that you can launch it and see how Heron works. So those examples are already there in the example directory. You are welcome to add more if you like to. Then the executed directory essentially consists of a simple Python program, which is the first program that comes up in a container, and then in turn launches other programs in the container, like the stream manager, as well as Heron instances and all the various metrics manager and other programs. And that is in the executed directory. And the instance is essentially the core of the Heron, where the execution of the topology occurs in terms of when the topology is broken down into the individual spout and the bolt instance. Those are all run on the Heron instance, and all of the code is under that instance itself. Then the metrics manager directly consists of the process metrics manager that runs in each container, and the corresponding code is there, and even some of the syncs that you might want to write to direct all the metrics to some other syncs, it's all there as well. And the packing directly consists of essentially several algorithms that we use for packing, how to efficiently pack a DAG into several containers. And so those different packing algorithms are available here. And some of the algorithms include a round robin packing, which is very simple. And the next one is a first fit decreasing algorithm, which is also simple, but it allows for heterogeneous containers as well. Then the proto contains protocol definitions for going back and forth between stream manager instance and stream manager master interactions, and all the protos are there. And the scheduler code essentially takes care of the abstract scheduler and how Heron schedules its job, and that's all in the scheduler code. And the individual scheduler mapping, where the code is supported by an implementation, is all available in schedulers. For example, if you wanted to look at the scheduler code for Mesos, you have to go into the schedulers, where the specific implementation of Heron running on Mesos is available here. Then the stream manager essentially contains all the code that deals with the stream manager. And finally, the team master code contains of the code that a team master is executing, especially when it manages the life cycle of a topology. And finally, the uploaders code, where you have multiple uploaders. When you upload a job, you can upload it to a particular stable storage. That could be a local file system or a Hadoop file system, or even it could be an S3. So all those code is available here. The one thing I forgot to add is something called a state manager, and the state manager code is also available in the code base. And the state manager essentially supports how the state of a Heron topology is stored and manipulated when the topologies are running. And that is essentially the job of state manager. And the mapping of state manager to a local file system as well as a zookeeper is already available in the state manager. That's all. Thank you.